So here we're told that material A costs $3 per kilogram and material B costs $5 per kilogram. And we're told that 10 kilograms of material K consists of X kilograms of material A and Y kilograms of material B. So that means X plus Y is 10. So that's the first relationship. And the question is X greater than Y? So in the mixture, is there more of material A than material B? Statement 1 says Y is greater than 4. Well, that doesn't really tell me anything. All I know is the sum of those two amounts is 10, because here if Y is 4.5, then X is 5.5, because they have to add up to 10. This would answer it as yes. If Y is 7, X is 3. Now the answer to that question is a no. So we don't have a definite answer to the question. So 1 alone is insufficient. Now 2 says the cost of 10 kilograms of material, so the cost is less than $40. So there are two ways we can do this problem. This second statement. The first is the cost for X kilograms of material A would be the cost per kilogram times the amount, which is X kilograms, plus the cost of material B would be 5Y. And the condition is this is less than $40. So that's the relationship. But if you think in terms of using a weighted average approach, we're looking at 10 kilogram of material. And we have, let's say, on one extreme, material A, material B. This costs $3 per kilogram, and this costs $5 per kilogram. So if the entire mixture was material A, the cost would be $30, because we have 10 kilogram. Each kilogram is $3 per kilogram. If the material K was all made up of material B, then the cost would be $50. And you would see that if we use half and half, 5 and 5 would be just right in the middle, the average, which is $40. And now we're told that the cost of the mixture is less than $40, so it falls somewhere here. And that means for that to happen, I would have to have more of material A than material B, which means X is greater than Y. So we have a definite yes. So 2 alone is sufficient. So that's one way to do it, sort of conceptually. The other is doing it algebraically. So we have this relationship, 3x plus 5y is less than 40. And we also know x plus y is 10. So I can express y in terms of x. Y is 10 minus x. And I'll replace that in this inequality and see what it says about x. So I have 3x plus 50 minus 5x. And then I subtract 40 from both sides. This is 0. That's 10. So plus 10 less than 0. This is minus 2x. And then I add 2x to both sides. I get 10 is less than 2x, or 2x is greater than 10. Divide both sides by 2. I get x is greater than 5. I know x plus y is 10. So if x is greater than 5, y has to be less than 5. And that means x is greater than y. So that's the other approach, the sort of the pure algebraic approach for statement 2, which is really, it is actually a weighted average problem where you're given a mixture made up of two different materials. But you can take either approach depending on your preference. But statement 2 alone is sufficient. The answer is B.